that I said that we can represent our probability using functions. Now, I've said that over and over again, but it means that we sort of combine the summary statistics and our measures of spread and measures of central tendency and things like that, right? So mode, for example, we know is usually the most often occurring score in a data set, right? But what does it look like in terms of a function? Like, how do you have a mode for a function? Like, if I have something like this, what was it? Yeah, the highest point, right? Because remember, what do these actually represent? These are probabilities, and these are x values, right? So the idea is, if you have a particular point over here, you want to, well, that's not the highest point. The highest point would be here, right? That's the highest point. The maximum point there, that's going to be your mode. So I'll show you some examples of questions in a moment, but more often than not, the ones I've seen, they're more visual. So the highest point, the max there, is also the mode. Now, important to note, it's not the y value we're interested in. It's not the probability. It's like the actual score itself. If you think about like writing out your scores, the mode is not how many of them there are. Like if you have 3, 5, 5, 7, the mode is not 2 because there's 2 5s, but the mode is 5. Like 5 is the score. So the x value is what you're looking at. I shouldn't use x twice. Yeah, but like if that was 3 or whatever. No, that's 5. What am I doing? Sorry, I'm just jumping all over the shop. So that's 5 there, right? That's just an example. Yep. So the mode is the x value of the maximum points on a PDF. Okay. So the mode is the one that occurs the most often, right? But in terms of our function values, like it doesn't really make sense, oh, what's happening the most often here? Well, we look at what's the highest point. That's the idea behind it, okay? I'll show you some problems on the projection in a second. I just wanted to recap the other ones as well. So median and other percentiles. Same idea, right? Like we were just doing some problems on the median, but we can do the same thing with percentiles, right? How can we approach this? Median, remember that we can either use two approaches. You can use the PDF or you can use the CDF. The CDF is the running total, and that is you can let that equal to half, okay? Another approach you could take is if you know the domain, which is this is defined, which I should give you, 4 to 9. So this is defined in the domain 4 to 9, okay?
What did you say? Probability density?
Density function, yeah. So this is a PDF that we're given. So I can use the CDF by integrating and then using it that way. Or what you can do is you can actually also use the PDF. Because remember, they're closely related. All you have to do is integrate the PDF to get to the CDF. You may not have to do the full working out for that. What you could say is, all right, well, if I want to integrate this, and this is a curve you can look at, right? And what I've been showing you guys is, if you think about it visually, so from 4 to 9, something like that maybe, 4 to 9, the total area under this curve, what's that equal to again? For probability density function? Yeah, 1, right? The whole thing's equal to 1. The median is the score that is like half, that gives us half of that area, right? So just half. But there's an issue. Why can't I just take the average of these two values and then just get half that way? Oh, yeah. Yeah, because it's on a straight line. Because when you do it with a straight line, you could do that. But because this is a quartic, right, actually it won't quite look like this, right? The halfway point might be over here somewhere or whatever, right? So there is some value, you could call it like C or whatever, that gives you half of that area, if that makes sense. That makes the area equal to half, yeah? So that's why you can't just take the average of these two values, because the idea is that there's some score here that gives you half the area. It won't necessarily be the average of these two, particularly when you have functions like this. So what you can do though, is you can integrate from 4 up until some point. So you could choose like C as some number, right? And then you can then integrate, because you want that, what do you want this number to be equal to? What should it be equal to? The area under the curve for the up to the median. Half, that's right, yeah. So that's like a similar process to doing this. Essentially the same thing, because remember the CDF is just integration anyway, and you're going to substitute in some values. But you could just do it this way, right? So let's integrate this. So we know we get x to the 5 over 1160. That's what happens when I rush. So that with the bounds C to 4 to C. And then we substitute it in. Sorry, my mistake. So C to the 5 over, let's do it myself, 116. 58,205. And then take away, and then you substitute in the 4 at this point, so 4 to the 5 over 58,205 equals to half. And then let's collect like terms, right? So move this guy over to the other side, just add it to it.
I think it's 58,025.
Oh, is it? Sorry. Yes, you're right. 025, thank you. Again, rushing. So then let's add this guy onto the other side. And then multiply by this guy. And then, sorry, a lot of like different operations that we're doing here.
I think you went the wrong way around, sir.
Is there an easier way?
You should have just multiplied by 58 over 2.
Oh yeah, why didn't I do that? My mistake. Sorry.
I mean,
Is that what you guys did? Yeah, you guys do whatever you want. Yes,
So
yeah.
you can still number.
Yeah. That's alright.
7.861.
Oh yeah, see how much further away it was? Like
Pretty far.
7.
Yeah, boss, it's far.
Yeah, so that's our number. Any questions on that? Sorry, that was a bit of a roundabout way of solving. Does that make sense what we're doing there? So the idea is you want the area to equal to half. So you're kind of working backwards, Lauren. And you're saying that the area is equal to half and you're finding what x value you need for that particular bound, right? 38th percentile, you can do it in the same way, right? So for part B, 38th percentile, all you need to do is you want it to equal, well, what is the 38th percentile? It contains 38% of the data, right? 0.38, yeah. So same idea? Okay, since we have the integral,
Lauren, I think it was you.
why don't we just use this one? So we can skip straight to this if we're doing it twice, right?
It's pretty smart, actually, so. It's pretty big brain.
Thank you, Matt.
Is it big brain or like brain brain?
It's just brain.
And then what was your trick, Matt? You multiply it by 58,205?
Sorry.
Was that what you did?
I guess it's, yeah, you can call it a trick if you want.
So multiply, so get rid of the fractions.
Didn't you say it was 025?
Did it again. Sorry.
Doing good, sir.
You all good, sir.
Yes, Kingsley.
I'm excited to show you the next example.
The hype is real.
Can you repeat that?
So we're expecting this to be what? It should be less than the median one,
Not
right?
much less, though.
Not much less. Weird.
That's pretty good.
Is that right? Is that what you got there?
Wait, can you put it down?
7.45? Yeah, sorry about that.
Why did you spend your
There you go. Last one. There you go. Sorry, last one before you guys go. So here's the last example, right? So this is showing the mode. The question's asking for which of the following is the mode. And what did we discuss? The mode is the one that occurs the most often. But what am I actually looking for? I'm not looking for the probability that it occurs, but the score itself, right? Exactly right. So out of all of these, they have some distractors that they're trying to give you. But remember, it's the x value of the highest point that's there. 0.8 is our answer for that one. So C. And that's a kind of example. That's from the Nessa sample paper. So you can have a look at questions like that yourself. Okay. All right, cool. I hope that's enough for you. That's the end of what we got. I think, what exercise are we up to? 14.04 now, I think. Yeah.